Nearly 1/4 of the world's population is suspected to have been exposed to the bacterium responsible for tuberculosis, a disease that accounts for the highest global mortality from a bacterial infection. TB's global distribution was once viewed as support for its emergence deep in our past, where it was thought to have evolved in Africa tens of thousands of years ago and became distributed throughout the world following migrations with its host. Its ability to infect a number of mammalian species also make it a highly adaptable pathogen. Analyses of ancient TB genomes have stirred up controversy about when this host-pathogen association began and precisely how TB became globally distributed. A 2014 study led by research teams at the University of Tübingen and Arizona State University reported on 3 ancient TB genomes from coastal Peru, which revealed aspects of its history that were incompatible with prevailing assumptions on TB's origins. First, rather than identifying one of the well-characterized human-associated strains of the pathogen, the team identified a comparatively rare strain that today infects mostly marine mammals such as seals and sea lions, pinnipeds. In addition, their data suggested that TB was a much younger disease than previously thought, having emerged only sometime in the last 6,000 years. It was not clear, though, if the specific TB infection we identified in the 3 people was a local phenomenon restricted to the area, or whether its distribution was broader. TB is an infection well known to specialists in bone lesions and pathology. We've known for decades that a form of TB infection was present in the western coast of South America through the study of human remains. All 3 people were infected with the marine-associated strain of TB, thus making a simple zoonosis from seals unlikely. TB's entry into South America through human exposure to infected seals is still the strongest hypothesis, but how TB was subsequently distributed on land remains an open question. It's an exciting time in ancient DNA research, as we can now look at genome-level differences in these ancient pathogens and track their movements across continents and beyond. For TB, the open question is how widespread the seal-associated strain was in human populations of the Americas prior to its replacement by the more virulent strains that arrived with the Europeans. Make a difference. Sponsored Opportunity Story Source. Materials provided by Max Planck Institute F. Note: content may be edited for style and length. 2022, March 10. Exploring Ancient Tuberculosis Transmission Chains. Science Daily. Retrieved March 10, 2022 from ift.tt/ginfeud Max Planck Institute for Evolutionary Anthropology. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.